Hello, everyone. Welcome to our CATIA Systems Talk. My name is Gitana Strazdauske, and our topic today is MBSE Digital Engineering Ecosystem. My guest is our subject matter expert and a good friend of mine, Saulius Pavalkis,
Thank you.
MBSE Ecosystem Director. Integration between tools and disciplines is a major direction of MBSE and digital engineering. In this session, we will present the SysML model of all integrations covering the MBSE, ecosystem integrations, internal and external, use cases, and integrations maturity. During and after the presentations, you will be able to ask questions to Solus in the chat. Please don't miss this opportunity. One new thing, due to the importance and scope of the topic, you will get two sessions, one of which will be now. We will announce the date of the other session soon. So my introduction is finished, and now we're ready to start. Solus, the stage is yours.
Thank you, Gitana, for an introduction. I'm really glad to be here, and let me introduce myself. I'm a global MBSE ecosystem director, and also I'm R&D cyber portfolio manager representative here in North America. And my education by background is actually started already when I was working in the model-based area at the company. I got my PhD from Models Queries, and now I'm also advisor at Texas University at Arlington. My work experience is as a chief solutions architect, trainer, analyst, quality assurance engineer at the beginning, and now integrations director is from Magic, now Deso, acquired by Deso Systems, Katia brand, and also I was contractor for JPL doing system engineering trainings and consulting, Boeing for MBSE adoption, and now currently Northrop Grumman contractor for MBSE adoption. My certification is ESEP and Expert System Engineering at Incosia, and also I have OMG certification for the UML and SysML. A lot of time is spent also contributing to community. We have a YouTube channel for MBSE execution for the digital engineering, model-based digital engineering, mostly for simulation of SysML and integrations. Also, we have Katia MBSE Cyber Systems community, which is the main community where we post all the new material, including this webinar is actually even delivered through that community. And you can find after this webinar recording and slides and even the project of the integrations, which we will show today in this. And also I do a lot of papers that represent company at different conferences like Incosia, Models, OMG, and DAA. So with that, I'm very happy to present today's topic. It is we will talk about the source systems engineering ecosystem, model-based systems engineering ecosystem. Then we will talk about Katia Magic, Cameo, MBSE integrations, and the source systems integrations. And then we will talk about, in general, all the integrations. And then we will go to the highlights. Highlights will take the most time because this will be the difference between last year and this year, what we have prepared for you. And there is a lot of things coming. So first of all, what is digital engineering ecosystem? And we got updated digital engineering strategy last year, end of the year by DoD. And there was identified that actually no longer model-based and digital engineering is optional in the system engineering and model-based acquisition activities. This is must for new projects in digital in DoD. Also, all projects are strongly suggested to consider that. So system engineering and model-based acquisition is the two places where the model-based system engineering and model-based is applied. And there is also definition of digital engineering ecosystem where we can see that it's it includes infrastructure and architecture necessary to support automated approaches for system development, design, testing, evaluation, production, operation, training, and sustainment through the defense acquisition process. But also it's interesting that infrastructure consists of the following digital engineering ecosystem assets. Here you see those assets: it's tools, workforce. This is actually, we always were saying that the people is the key, because you need to grow and educate on digital engineering. Then also software, networks, which was new for us, because normally we don't consider networks as important, but actually more and more important because of the distributed ecosystem, right? You have cloud, you have on-premises, you have suppliers communicating, and also cybersecurity, right? Networks are important, right? Classified, non-classified, and then hardware also very important. Now, from the SOS systems side, but also in general, the vision is virtual twin. And what do we mean about virtual twin? So virtual twin is not only the digital twin, like a digital copy of the 3D environment where the system, how the system looks like, but actually virtual twin is the whole engineering digital thread, how the system was made. So what it enables is actually enables continuous update of the system. And you can imagine that that's like requirements, system architecture, design, would it be mechanical or electrical or software design, and then actually full copy of the digital system, which we can update based on real world events. So real world is in the loop. That's the vision, right, where we are going. And if we will take a look from system engineering side, model-based system engineering side, we have requirements, we have user needs, we have system architecture, we have design and implementation and integration, and then unit testing, verification of the system, and then validation of the system, and then the cycle continues. And all of that can be done virtually and is done virtually, but in many cases it is disconnected because different tools disconnected, right? Not model-based, so then integrations are like hard-coded, right? And what we are talking about is model-based integration through all the engineering, system engineering process and virtual twin. So here we can see system engineering ecosystem from 3D experience platform perspective. And you saw this last year, right? And I will talk about it in a little bit different view. So here we see updated view. We can see that we have not only system architecture, as you see here, where we have Katia Magic, Cameo, right? But also we have project management, data analytics, dashboarding. We have Enovia, which is like PLM piece. So this is like a change configuration management. Then we have requirement management. We have requirement simulation, right? With the stimulus, it's mostly system critical requirement simulation. Then we have traceability, digital thread. For example, if you want to do like, and you need to do like baseline between different assets like models or even PDFs, you can do it without even detailed traceability, just a baselining, but also it supports detailed traceability, collaboration. Then validation, verification of the design through the simulations. This is a very big part because of the CATIA simulations, right? Design disciplines, that would be like mechanical design, electrical design, including SolidWorks, CATIA, and software in the loop, system safety, and currently also cybersecurity, and behavior modeling, where we can simulate a multi-physics environment. Now, from the whole Katia Magic 3D experience engineering environment, we have perhaps one of the best fit in the industry. If you take modeling tools, MBSE tools in the market, not only that we kind of target the largest clients and the best standard compliance and usability, but also we have the due to openness in interfaces, we have a huge ecosystem, and that ecosystem, first of all, is internal. So we have a lot of alignment with the 3D experience platform, as you can see here. And here is Katia Magic, right? Would it be server side? Would it be plugins based like simulation? Would it be standalone 3D experience, the source system tools like Daimola, Rectify, Stimulus, Control Build, but also 3D experience platform digital engineering ecosystem. As you can see from the recent ones, we can see there is Power BI, and Power BI is ability to deploy the models without any distraction, just like commit, check in, check out, not only for Katia Magic, but also for Daimola, for Control Build, for Stimulus. That's like a good way to work in the native environment, like a native tool, standalone tool, and then ability to deploy to the 3D experience platform data for the backend. Also, what we see here is scale simulation, SSP, right, which we will talk a little bit more about in the highlights, which is coming new direction for simulation, multiple simulations orchestration, and a few other things. Again, this model is already available in the post in the community. So if you are in the community watching this webinar, you can download in the link this model and see those recent integrations and the whole ecosystem. And also at the end of this presentation, we'll give the link. Now, when we go to all the integrations which we have in the market, we can see the different areas covered, like requirements management, and there's new integration with JAMA, which we will talk more about in highlights. We have Jira, we have GitLab, we have ability to export to the documentation, we have analysis tools. Also, we have a lot of integrators like Process Composer internal, Rectify internal, like 60 connectors, but also third party like long-time friends, Sinde, Intercax, Inquiries, Labs, and others like SmartFacts and SB Vision. So now let's go to the MBSE ecosystem highlights. And in this first part, we will cover today three major integrations which we present. And that would be JAMA integration. This is maybe one of the most requested integrations in the years because requirement management is a big part of the ecosystem. So we need to support that. As you know, system engineering starts from requirements and ends with requirements for the design. So this JAMA integration is first one. Then scale simulation with new standard support SSP, which is one of the most successful Modelica standards continuation. FMU is one of the most successful co-simulation standards, and SSP is next one. It's orchestration of the FMUs for the simulation. So please check what's happening here, and we will present soon. And model-based design reviews. And all those integrations will be presented with the architecture and also with the video demonstration. In the part 2, something about in the month, we still need to find the date for you. We'll talk about SolidWorks integration, leveraging Power BI, which is actually not only for SolidWorks, but also for us and for multiple other standalone applications, seamless integration to ecosystem. We'll demonstrate how that works through digital thread together with MBSE and Katia Magic. Then we'll talk about server-side simulation for remote simulation integrations. We'll talk about Internet of Things and hardware in the loop, and we'll provide the libraries for you to enable any hardware integration and Internet of Things devices integration with Katia Magic. And also we'll discover what's new in MBSE2 via harness when we are allowing full transition from the system engineering to electrical engineering, and what do we present here, and system virtual validation in 3D environment. Okay, so now let's talk about JAMA software integration. So this is, again, one of the most requested integrations. We were working on this integration for a year with the corporate partnership between JAMA software and the SOS systems. And this integration is twofold. One part is actually to 3D experience platform, system traceability engineer analyst role. An app can use this integration connecting to JAMA software directly, actually two types of JAMA software on premises or the cloud. And also we can do using CAMIO Data Hub, which is actually our integration framework for the requirements to Katia Magic, same like DOOR, same like traceable requirement management on 3D experience platform. Now we integrate with JAMA, and that's the last and the best integration which we have with the requirement management tools. And you can read more about this integration and all other integrations in this link. You can download slides, click on the link, and you'll get separate posts with those videos presenting this integration. So now let's see how that works. So first of all, we are discovering how that works in the 3D experience platform. We have a system traceability app. Here you can create a connection to the JAMA repository and see requirements. So you see requirements with all other objects, right? So it's not only requirements, it's an application lifecycle management tool. JAMA software is application lifecycle management tool. So you can see also other objects like drawings and like test cases and so on, and you can just drag them, and say, okay, those requirements should trace to system engineering and design. And we see also, ability to navigate through those requirements. You see, we can see them visually. We can read the text. We can create traceability. We can collaborate, like create commands, create issues. We can see traceability in the table. Now let's transition to the integration with Data Hub to Katia Magic. And here we can see that we are using standard Data Hub capabilities. All that what you know already from DOOR, so traceable requirement management, is used here. You can click on the connector, connect to JAMA. You can choose JAMA on cloud or on premises. You can connect using different authentication mechanism. And you can now choose the project scope and then choose the what would be the template. Based on the project, you get the template, so the data set, and we provide out-of-the-box mapping. And here you can see in the Data Hub Explorer, we can see the tree, the same style tree with the icons, with all the data elements, same as you would see in JAMA. So you can actually work here directly, creating some elements and reviewing, and then establish scope of synchronization. So as you saw, we dragged to establish scope, and we can update mapping if we want. For example, maybe relation should mean different thing than what is by default. And in any case, those relations are more like specific in SysML than in other external requirement management tools, because of the SysML richness on both sides, like where the requirement traces, right? Depends on that is relation type. Now, as you can see, we updated mapping and we established synchronization. So we get data in, and in that case is requirements. And we see that, okay, all of them were synchronized correctly. And we see also the scope with the S adornment, that it is the one which was synchronized. And also you will notice that we have some image here in a moment when we visualize those requirements. And that came from the JAMA requirements ability to draw visual drawings as a representation of the system. And we can import them and synchronize as an image in the requirements. As you can see here, we got that information. So we can visualize based on traceability related requirements. Now those requirements are in the model. I can create a new requirement. I can add it and update my requirement structure here. I can also, as one capability specific for this JAMA integration, synchronize SysML diagrams to JAMA. So if you are using JAMA requirements and someone synchronizes SysML model, you not necessarily need to go to the model to see the diagrams. You actually can see those diagrams directly inside of the JAMA. As you can see, I'm mapping to text object. This is one way to map diagrams. You can choose other ways, but that's maybe the most flexible way to map the diagrams to JAMA and then see them inside of the JAMA. That's read-only. It's not editable because you need to have SysML logic behind to edit the diagrams, but you get latest synchronized diagrams based on your choice. Here we also see that the mapping is updated based on the recent synchronized elements, scope of the synchronized elements. If new element is available, it was not clear what, so the mapping update is requested. And here we see in JAMA. So we saw this original drawing, right? But now if we will open requirement model, we see this is the new diagram, SysML diagram, SysML requirements diagram inside of the JAMA requirement management tool. So now, as a next topic, we will talk about scaled simulation interchange, and that's using system structure and parameterization standard, SSP standard. Again, this standard is coming from Modelica Consortium, the one which is the author of the FMU standard, functional mockup unit and interface standard, which is one of the most popular co-simulation standards. Now it's like 200 tools. Just a few years ago, it was 150 supporting the standard. If you use that, you know that it's actually in many cases works out of the box. You can include license, you can exclude license in the FMU. But what from this standard perspective, what we have Katia Magic ability to interchange the model. In this July beginning release, we will support ability to export in IBD internal block diagram or instance-based internal block diagram to this SSP standard. So if you have like FMUs connected in the internal block diagram, you can export and then execute in other tool which supports SSP. So that's standard. You can export and you can execute in 3D Experience platform using new tools like System Simulation Designers, the trigram as SID, and System Simulation Analyst, SIC. SID is used to orchestrate, like create a dashboard, import the data, and SIC used more lightweight, used to execute the model. You don't need to create a dashboard, but you execute the model. So that's the first thing. And then the plan for the future, 2024 release 2, we plan, as you can see, red, so will be export from the stimulus requirement simulation engineer and control build SSP to execute in other tools like 3D Experience Platform, SID and SIC, but again also other tools like, for example, Daimola supports this SSP, and there are other tools in the market. And then in the future, this is still early consideration. 2026, we planning to have Power BI based ability to export SSP to run remotely, for example, on 3D Experience Platform, because Power BI is actually for 3D Experience Platform. Now let's see how that works. Here you can see system which has a water tank and controller. Both of them are based FMUs imported from external tools. So, for example, controller could be from Simulink, and water tank could be from Daimola. And then we can create instance of this internal block diagram. And when you create instance, you can provide input property values, right? And then we export to SSP. And now we are importing in 3D Experience Platform in SID tool, right? So here we see imported, same model from Katia Magic. And now we can create a dashboard, we can visualize properties, and we can track the execution and see how that runs. In the future, also, we are planning to execute this remotely, right? So we will be able to simulate remotely in Katia Magic internal block diagram using SSP standard. So currently we'll need to export in July release, refresh 1 release, right? But in the future, we plan to actually just run it, and that automatically would connect and execute the model in Katia Magic. So this will let you have external evaluator connect based on SSP executing model and us monitoring results, which we are, again, another capability I'm not presenting today, but we are releasing results play capability based, which we will be able to integrate in the future. Now let's summarize today's presentation. I will not go to the second part today because it would take another half hour, right? We have just half hour today, but we covered MBSE ecosystem in general by Dassault Systems and the digital engineering system engineering ecosystem, then digital engineering 3D experience and Katia Magic ecosystem in general, and highlights like JAMA integration, SSP standard support, and that's pretty much it. Now in the future, we'll cover model-based design reviews, Power BI by SolidWorks, server-side simulation, Internet of Things, and hardware in the loop, and we'll provide the libraries to do that. From MBSE to wire harness, what's new, there is a lot of new things coming, and system virtual validation. As a result, we are going towards virtual twin, which will integrate all the models, model-based way to enable fast virtual validation and verification, model-based system engineering, and acquisition. Here we see JAMA integration, traceability, Power BI based with the design alignment between system engineering, model-based design reviews, hardware in the loop, IoT, Internet of Things, system structure and parameterization standard support for the models execution, scale models simulation, and system virtual validation in the environment when we integrate with Katia Magic. So thank you for attending today, and please take a look at the content of this presentation in slides available in the community, including this model, which we demonstrated with all the connections like ports and tools we presented. And looking forward. questions.
Thanks, Saulos, for your time. And it's a very good idea to split the session into two parts. So, but I have a question. Even after the first part, I have a question. What is the vision of integrations in the future? Because what we heard, there are lots of work done already. And what do you think? What is the vision of the future?
So this is a very good question, and actually we can check the keynote from the MBSE Cyber Systems Symposium. Just posted 2 days yesterday, I think, in the MBSE Cyber Systems community. So I want to promote this community again. I can't say more better words because it is public. It's monitored by us community for MBSE. And our vice president for R&D, Frederic Borchier, posted the keynote he did at last week at the MBSE Symposium, where he presented R&D path forward with the roadmap, with all the details. And there is recording of this session, and there are also slides available. So that's just the most detailed you can get in the last, time slots, where we can share with you now. But also we already discussed a little bit here that it's virtual twin, right? So the virtual twin allows us to integrate system engineering in the loop of design and virtual environment for verification and validation and integration. That's the system design and testing and verification and validation virtually. Sure, we need to prototype, but like same as like manufacturing, you can 3D print. So same system engineering, you can deliver assets, and then manufacturing and implementation becomes much more easier.
I've just added this keynote as in the comment section after the post about this live event. So everyone who is on the community and who will visit, please go to this post, and in the comments area you will see the presentation Saulis just mentioned. So thanks a lot for your time, Solo, and for everyone who were together with us this half an hour. And let's meet in 1 month for the part 2, which will be announced quite soon on our community. Thanks a lot and take care. Bye.
Bye. Thank you so much.